In today's video, we're going to be looking at mean difference, weighted mean difference, and standardized mean difference. By the end of this video, we hope that you will have a better understanding of what each of these terminologies mean, how they are used, how they are calculated, and how to interpret the results. Typically, when you're reading a study, you'll come across two different types of outcomes. Dichotomous, which measures this or that, yes or no, binary results, or continuous outcomes, which is looking at results on a spectrum or a range, such as age, weight, or serving size. When you see continuous outcomes, you'll often come across the terms mean difference, weighted mean difference, and standardized mean difference. So first, we're going to look at mean difference. When you see mean difference, you'll know that you are comparing the mean values between two groups. Each of these groups should be using the same unit of measurement. Oftentimes, you will see these in single studies. So how does this work? You find the mean value of one group and you compare that to the mean value of another group to get the mean difference. So for example, we want to know the effectiveness of having tutors within high school students. So one of the groups had no tutors. You found out that their mean GPA is 2.86. Then you have a second group which had tutors, and you find out that their mean GPA is 2.94. So what does all of this mean? Well, first you take the intervention group's GPA, which was 2.94, minus the control group GPA, which was 2.86, and you find the mean difference of 0.08 GPA. But is this significant? We don't know, because significance is determined on statistical analysis such as p-values and confidence intervals. Next, we'll look at weighted mean difference. These are used in meta-analyses. Similar to mean difference, you are also comparing the mean value of two groups, but in this case, you have multiple studies. All of these studies are answering the same research question, and they are all measured using the same unit. Now, certain studies are going to have more weight than others, simply because they were better studies. You can determine this based on the study design, so was it randomized or not, looking at each study's sample size, and looking at the variability of the results. Going back to our example of effectiveness of being tutored in high school students. So you have one study that had tutors and one study that did not have tutors, and you're measuring the GPA. Then you found a whole bunch of other studies that did the same thing. So what are you going to do with all of this? First, we're going to decide and judge each of the study to see how we are going to weigh them. So depending on if a study was determined better or not, they will be weighted more. Then you calculate the weighted mean and the weighted mean difference. So let's do this together. We have the control group. Each of the study had the same control group, which was having no tutors. They all have the mean GPA. Then we decide to apply a weight on each of the study. So for example, say study 1, they had a small sample size and it wasn't randomized, so you're going to apply a smaller weight because their result might not be as reliable. And then you compare that to other studies that may be a better indicator. You do the same thing with the intervention group. You take their mean value, you apply a weight on it to get the weighted mean. Then you add up all of the weighted mean and you get a total weighted mean. So weighted mean is taking the mean value of each of the study, multiplying that by the weighted value, and then adding it all together. Now you have a weighted mean difference between 3.5 3 minus 2.91 and you get 0.625 GPA. You can also do this in another way by putting it all together. So all of the study had the same intervention and same control group. First, you find the mean difference between each of the group in each of the study. Then you apply the weight onto each of these studies. And finally, you figure out what the weighted mean is for each study. And then you add them all together and you get the same result. Finally, we look at standardized mean difference. Standardized mean difference are also found in meta-analyses. They're answering the same research question, but this time, each study is measuring them differently. So they're using different units of measurements. So what do? We need to standardize all these results so that we can actually compare them. This is based off of a standard deviation, and you find a statistical value, which is not a unit of measurement. So the SMD is a stats value, not a unit. So going back to our favorite example of effectiveness of tutors in high school students, say you have in study A, they looked at GPA results. Then you look at study B, and they looked at university admission rates. Study C looked at failure rates. And finally, you have study D that looked at final exam scores. So you have a bunch of studies asking the same questions, but measuring them all differently. So then what do? First, we need to standardize all of the outcomes to a single measurement by using the standard deviation. Then you aggregate these results in a meta-analysis to produce the SMD. Now, this SMD is going to be a single number, statistical value, so you need to interpret it. Think of a spectrum, and in the middle you have 0. On the right-hand side, you have a positive effect. So anything on the right of 0 will have a positive effect, and anything on the left side of 0 will have a negative effect. So if you see an SMD of 0, it means that there's no difference between each of the groups. If you see an SMD greater than 0, then the intervention had a positive effect. And finally, if you see an SMD less than 0 or a negative number, you know that it had a negative effect. So in summary, we looked at mean difference. We know that these are used within one study and they're using the same unit of measurement. We do this because we want to compare the intervention group to the control group. This is found by finding the mean of each group and then taking the difference. Then we have weighted mean difference. These are used in meta-analyses. They are also using the same unit of measurement. We do this because we want to be pooling a bunch of studies together that answers the same research question and uses the same unit, and comparing the intervention and the control. How do we do this? Well, there are two ways. You can find the weighted mean of each of these groups. So you get the mean value from each study, apply the weight that you had determined, then adding them all up together, then taking the difference. Or you can figure out what the mean difference is from each of the study, applying the weight that you had determined, adding all those together to find the weighted mean difference. Finally, we have standardized mean difference. These are also found in meta-analyses, answering the same research question, but they are all measured using different units. So then we have to standardize all of these study outcomes so that we can pool them all together, and again, comparing one group to another. You do this by using standard deviations. So SMD is found by using the mean difference divided by standard deviation. So we hope that at the end of this video, by now you understand the 3 different types of mean difference, how to use them, how they are calculated, and how to interpret the results.